Hello students, welcome to the Learner's Planet. So students, this will be our third problem solving session for AIEEE Chemistry Paper of 2011, right? So till now we have solved around 20 questions of the AIEEE paper. In this session we will be solving the remaining of the questions, right? So students, actually this particular thing is to give you a practice or an idea of how the paper is, right? Because from the past papers, the previous year papers, we get the idea that what sort of papers are given in this exam, or what sort of questions are asked in this exam. So now let's start with our session, students. Now here our first question is, boron cannot form which one of the following anions? Now students, to which group this boron belongs? Now your boron belongs to the 13th group or third group of the periodic table, or third B group, right? Now what is the electronic configuration of boron? It is 2s2 2p3, right? Now what is the maximum covalency shown by boron? The maximum covalency of boron is 4, right? It can accept one electron. Whereas the other elements of this group, like aluminium, like gallium, indium or thallium, they are showing maximum covalency of 6, right? Now see, in BH4 the covalency is 4, this is 4 and this is also 4, right? But BF6 boron cannot show 6 covalency, so this ion cannot be formed by boron, right? So students, while solving such a sort of questions, you need to know the maximum covalency shown by that particular element, right? And let's take up the next question, students. Yeah, it is, which of the following statements regarding sulfur is incorrect? Now students, see, the vapor at 200 degrees centigrade consists mostly of SH rings. Now in such sort of questions, now here students, you can't just remember the facts like this, that the vapor at 200 degrees centigrade consists mostly of SH rings. It may be or it may not be. At 600 degrees centigrade, the gas mainly consists of S2 molecules. This is correct. Now here, find out for the incorrect option straight away. See here, the oxidation state of sulfur is never less than +4 in its compound. Is it so? The oxidation state of sulfur can be -2 to +6. So it can be less than +4, and so it can be -2 to +6. Now this is your incorrect statement. This is a question of just one statement correct. You have chosen this one statement correct, right? Because you can't remember these things, that the vapor at 200 degrees centigrade consists mostly of SH rings. At 600 degrees centigrade, the gas mainly consists of S2 molecules, and S2 is paramagnetic. This we know. According to molecular orbital theory, this S2 comes out to be paramagnetic, right? So this is your wrong option. So just choose for the incorrect straight away. Though you will get one or the other statement which is logical, or which you can pick out, right? So it's not that you can say that, ma'am, this can be asked for your iodine or any of the element. So how many facts you are going to remember about each and every element? Do try to pick up the statement which is incorrect, and that will be definitely related to its oxidation state or covalency or any other character. This statement can be S2 is a diamagnetic. That is also wrong. With that, whether it is diamagnetic or paramagnetic, you can make it out from your molecular orbital theory concept, right? So this is the answer of your question. let's take up the next question, students. Yeah, this is the structure of IF7 is. Now students, in order to find out the structure of IF7, what you want to know is, or what you should know is, you should know the hybridization in IF7. This you must know. Now how will you find out the hybridization in IF7? See, just sum up the valence electrons. So how many valence electrons are there in iodine? 7. How many valence electrons are there in fluorine? 1. And there are 7 fluorine atoms. So it is plus 7. The total comes out to be 14. Right? Now if the sum of the valence electrons is between 8 to 56, you need to divide that particular number by 8, right? So the number of valence electrons you have found. Now here what you are going to do is, so students, I have made a mistake over here. There are 7 fluorine atoms, and what is the number of valence electrons in fluorine? The number of valence electron in fluorine is 7. Right? Sorry students, I have made this mistake. The number of valence electron is 7 and there are 7 fluorine atoms. So it comes out to be 7 plus 49. So what will be the thing? It would be 56. Now divided by 8. So there are, what will be 8 7 is 56. So there are 7 hybrid orbitals. Right? So what is the hybridization here? It is sp3, that is 4, and d3. So hybridization is sp3d3. Now what will be the shape of this? It comes out to be pentagonal bipyramidal geometry. Say this is your pentagon, right? And the fluorine atoms are present at its corner. And we have one down and there is one up. Right? So this is a pentagonal bipyramidal geometry. Right? So this will be your answer. So students, in order to determine any of the structure, what you need is, you need to know about the hybridization. Right? Now let's take up the next question, students. Yeah. This is ozonolysis of an organic compound gives formaldehyde as one of the products. This confirms the presence of. Now see students, what is obtained is formaldehyde. Right? Now ozonolysis is what? That is your acetylene or your ethylene. Right? Here it can be R. Now they are subjected to ozonolysis, or they are treated with O3. Right? Now here what you get is R, C double bond C, and I have got oxygen. Right? And here it can be R or H, anything. Likewise, here what am I getting? It is R, this is O, and this is again C, this is O, and this is O. Right? Now what is the one of the product? Which is formaldehyde. Right? So students, what will be the, it is definitely not a triple bond. Right? It is not a triple bond over here. Now this will undergo a Y-shaped cleavage, and here it will form what? HCHO and RCHO. Right? So what type of group should be present there? There should be a vinyl group present. So what is your right option? A. It should not be isopropyl, it should not be acetyl-NEC triple bond, or it should not be 2-ethyl-NEC double bonds. There has to be a vinyl group present over there, then only it will form one molecule of formaldehyde. Right? So, this is the answer of this question. Let's move to the next question.